How's everyone doing today? So what we're going to talk about today is we're going to talk about IMAP and DNS. My name is Calvin Barber, and I'm doing this for Kennesaw State University and for the class of ISA 4220 with Andrew Green. Let's get started. So the agenda today, what we're going to talk about is IMAP, which is Internet Message Access Protocol. We're also going to talk about IMAP hardening tactics, and then we're going to talk about DNS, which is Domain Name System, and then we're going to talk about DNS hardening tactics as well. Let's get into it. So right off the bat, what we're going to talk about today is we are going to talk about IMAP first. Getting more into IMAP, the IMAP method is basically connecting to a server to read incoming mail from a modern email program. So like for instance, just giving you like if you ever had to set up an email account before, you've probably like been asked which protocol you would like to set up, POP3 or IMAP. POP3 we talked about previously last week. And so you're going to be asked when setting up an email server if you want to set it up as POP3 or IMAP, and it's like a mind-boggling question right off the bat if you do not know like anything about the two, which I previously didn't know about them at all. But it makes a big impact on your experience, whichever one you choose, because they're very different, and the different advantages that IMAP has compared to POP3. And then so getting into the IMAP standard ports, those ports are going to be the standard port that it uses is port 143, and then also offers the TLS security port for 103 or 143 also, and then also it has the SSL security port, which is 993 that it uses. Getting into some advantages that we previously were talking about just a few seconds ago. Some advantages that IMAP has compared to POP3 are there are several advantages using this. Basically, you can access your email anywhere from multiple different devices. So if you have it on a computer or your mobile device, for instance, if you have Apple Mail, like I have Apple Mail on my iPhone that I use when I'm not using or I don't have my computer with me. But with POP3, you cannot do that. So a lot of email servers and a lot of users use IMAP instead of POP3 because it's more friendly user. It's more friendly to use and it's easier to use like that. And then it only like it downloads a message when like you click on it. So like it just doesn't download something right off the bat. You have to click it to download the message, and then basically the attachments for like attachments on emails, they aren't downloaded because that's how IMAP is set up. Like basically attachments that people send you in emails don't automatically download, so you can look through your emails faster and they load faster. And then a huge thing that IMAP offers compared to POP3 is basically all of your emails are stored on their servers and they will always be on their servers. So your email client will have to contact the IMAP server to gather your emails instead of POP3 where your emails would be on your computer, so you are in charge of backing up all your emails, and you could possibly lose your emails if you would lose your computer or anything. But with IMAP, they're on their own server, which is a big advantage. So getting into some IMAP hardening tactics, basically you want to be disabling like any open relay on your virtual servers, and then like preventing any anonymous access on your virtual servers for IMAP. And this will just allow for like limiting any attacks that would be possible for your computer, and then educating your user about email spam, because if you educate the user, like there can be hackers like trying to put Trojan horses in your email or anything like that. You can educate them not to click on something that would harm their server connecting, or their email client connecting to their IMAP server and possibly losing that email. and then also deploying front-end servers for hardening. Getting over into DNS, DNS is basically, it's the standard suite for protocols, which basically means it's like DNS is the standard suite of protocols that hold like the TCP and then IP. Basically, it's used to manage public names of websites and other internet domains, and then it's basically a worldwide. DNS is it's a worldwide collection of DNS servers that, like, when the user types in different websites into a web browser, the computer like basically automatically finds that address on the internet using the DNS servers. As of right now, currently there's 13 root servers. These contain like the complete database of names and addresses, and then all DNS servers are installed at lower levels of the hierarchy and maintain only like different like certain pieces of overall like the overall database. And so those 13 root users, and then there's a whole chart. I wasn't able to put it into the PowerPoint, but it's pretty cool. It was made up in Visio. And then getting down to DNS server connecting with your home network. This is just basically how your home network will be connecting with the client, and then as I was talking previously, how it connects, how like the DNS server connects with your home network and then goes out to the different servers. So whenever you're typing, as I was saying, like a website into a web browser, it will connect out to another DNS server to gather all the information for that website to bring it up onto your web browser. Getting to some DNS hardening tactics, basically making a checklist of DNS threats to, this will ultimately just help you all together break down what threats are for your server specifically, and be able to help you map out different protocols that you will need for your server to setting it up. And then just using default catches is extremely helpful. And then also isolating DNS functions. Basically, this is like the first step preventing attacks for DNS servers, is to plan like your network infrastructure so that you can like isolate DNS server functions. And like there's two different functions that lead to this, and then just to maximize the security, it should never perform both functions like simultaneously. So both of the functions, they should never be the same thing. It should be done separately. And as I was talking about like catches, like DNS tampering, it's the one of the number one problems like when you're using default catches. So if you use the default catches, make sure they're on and not off, and basically you don't want different ones on that you do not know, because it's like one of the most common methods for DNS tampering is catch poisoning, in which the attacker like injects fake records into the DNS server's cache, and then it just automatically just modifies the DNS records, and it can do like forged packets, and then it can just cause all kinds of like middle attacks to your DNS server, which is not good at all. So just make sure you're using default catches. These are my references that I used to find some of the information, and it was very helpful. So if you have any more questions or further questions or anything that you want to look up yourself, these are some great references to go to. And then thanks for watching, and we'll see you next week. Thanks, guys.